Good afternoon. I'm Francis Levy, co-director of the Philip Tatey Center. The Philip Tatey Center began as a discussion about imagination, imagination being the palette of psychoanalysis. We are interested in what creative people who have particular intense relationship to the imaginative life could tell us about analysis, and conversely, what analysis could reveal about the process of creativity. Welcome to modern cosmology. I am now pleased to present Dimitri Nanopoulos. Dr. Nanopoulos is Distinguished Professor of Physics and Mitchell Heap Chair of High Energy Physics at Texas A&M University. He is a Fellow of the Academy of Athens, Greece. Dr. Nanopoulos, who previously participated in the Philip Tatey's Roundtable, Mind versus Soul, will moderate modern cosmology and introduce the other panelists. Thank you.
Good afternoon. Thank you for coming for our session here. I'm very pleased to be back here. Let me introduce the fellow panelists here. Let me start with Janna Levin here, who is Professor of Physics and Astronomy at the Barnard College. Her work focuses on early universe, chaos, and black holes. She's the author of How the Universe Got Its Spots, and of the novel A Madman Dreams of Turing Machines. Welcome here.
Thank you.
Let me continue with Professor Weiming Tu. He's a chair professor of Chinese history and philosophy and Confucian studies at Harvard University. He's the director of the Harvard Yanqing Institute and a fellow of the American Academy of Arts and Sciences. His research interests in Asian philosophies comparative religion, and dialogue among civilization. He has published extensively on the modern transformation of Confucian humanism. Welcome to the panel. Let me go on with an old friend of mine, Piet, who is professor at the Institute of Advanced Study in Princeton. He heads the program of interdisciplinary studies. He's an astrophysicist with interest in the history of the universe and computational science, and he is the author of many books and articles that explore these areas. And last but not least, Professor Charles Liu, I think is known at least in the New York area, is professor of astrophysics at the City University of New York and the Staten Island, and also associate in astrophysics at the Hayden Planetarium and the American Museum of Natural History. His research focuses on the star formation history of the universe. He is the author of Black Holes, Quasars, Time Warps, and also author of One Universe at Home in the Cosmos. Welcome. Now, let me say a few words what we're going to do today. As you have seen, the theme of our discussion here is modern cosmology. The word modern has a very special meaning here because during the last, let's say, 10 years or something like that, we have an explosion of knowledge in what we call, in this thing that we call cosmology, and this is related with the origin or the appearance of the universe and its evolution until today. Cosmology really, with the physics point of view, it is really related with the first moments of the universe. And despite the fact that this sounds like a little bit metaphysical or philosophical, or I don't know what the words to use there, these words I don't like very much, during the last 10 years, it has been, I just put randomly that the 10 years, not 10, 15 years, it has been an explosion of experimental and observational data that has changed really our view about the universe. And it is clear that the new view that we have from this point of view definitely is going to change, I think, the whole world as we see it today. Now, let me remind you that the evolution that it happens in our planet after the 17th and 18th century, that we have this explosion of knowledge after the dark ages of 1,000 years, whatever years it is after the end of the Greeks, that we have this kind of development. We have Galileo, Kepler, Galileo, Newton, and then starting with Voltaire, we have now the kind of new development in a society, so that this knowledge that has been developed and is related especially to specific quarters has been really used in the society, and then we have the whole revolution to hell until today. I believe that we're living in a kind of new type of era like that the data and the new knowledge that we are getting at this moment, as we know, for this thing here, I think is going to change completely our views of the universe, and I have no doubt that eventually, maybe not in our generation, because these things are passing through very slowly, as you know, they're not trickling down for this thing, is going to change us and the way of living and where we're looking at the world and what we believe in a very dramatic way. So what we will do today, it is, I believe we have now a panelist of very important people that have contributed to this thing, and also we have here to the left of my professor that he's working how these things can pass through to the society. So what we're going to do here is we're going to discuss a little bit these new developments in a very, very simple way. As we discuss between ourselves, this is not going to be presented everybody's little model or something like that. Here we're going to present the central kind of way that we're thinking about the universe today. Then we're going to discuss a little bit between ourselves, and then we're going to open the floor to the discussion, right, for this thing. So in order to start this thing, I would like again Professor Levin now to tell us a few things, and then we go around and then come to your please.
Well, I was kind of amazed because you stole some words that I literally wrote about a week ago, which is that something about cosmology changes our conception of the world and thereby changes us. And that's a very strange notion. So I was thinking back to Copernicus. I mean, can you imagine living before we realized we were not at the center of the cosmos? This is such a major shift. And then I think about some of the things that are going on now, the idea that we know that the universe is expanding, and not only is it expanding, but the expansion's getting faster and faster, it's accelerating. We don't understand what the major constituents of the cosmos are. We don't know what the kind of matter is that's out there. We know it's not like us. We don't know about the major component of the energy, the dark energy. We know it's not like us. And these things should be enormous changes in the way that we view the world, and yet I think they're a little too abstract for us to grasp in our everyday lives. I mean, displacing us from the center of the universe is huge. I mean, you can see how that changes everything. But it's hard to know if people really realize that the universe is expanding, how it's really going to change them. And I don't know if you know this Woody Allen line in Annie Hall. Who knows? He says he won't do his homework because he's having an anxiety attack because he realizes the universe is expanding. And his mother tells him, "You live in Brooklyn.
Yes.
Brooklyn is not expanding." Yeah. So people, when they learn it, there is this moment of maybe anxiety, but there's also a sense in which we don't relate to it. And I'm banding about these same ideas. How much is it going to fundamentally change the culture that we live in?
Yes, it's really, as you already said, it's so amazing that in the last 10 years or so, we have learned so much about cosmology. When I was a student, cosmology was the part of astronomy which was most uncertain. It was almost like mythology. We knew a little bit, and which was already enormously interesting, because 100 years ago we knew virtually nothing. What little bit we knew was extremely interesting, but still very general and vague compared to the rest of astronomy. To put it in context, 100 years ago, we did not even know whether the universe had a finite age. Actually, the general idea was that the universe must have been infinitely old. It would be too human, too limited to think that the universe is born and maybe dies. That is something humans do, but the universe as a whole has to be infinite. That is the most appropriate, the most logical idea. So people thought, even to the point that Einstein famously invented his cosmological factor to make the universe able to have an infinite age, which he later retracted, and we now had to, on observational ground, had to reinstate.
Because he can't make a mistake.
For different reasons. Yeah. Yes. So we now know that the universe is finitely old. And for most of my career, I had to tell my friends that the universe is between 10 billion and 20 billion years old. And for me, that was enormous precision. The fact that it is finite, that is already important. That within a factor 2 we could know how old it was. That was incredible. But then, in the last several years, we suddenly have this flood of new observational data with the WMAP satellite. And now we know the age of the universe to within 1%. We know that the universe is 13.7. I just was in Japan for a few months, and there the units are 40. So you have 137 units of 10 to the 8. In English, 13.7 billion years old, with an uncertainty of 1%. And most of my friends, I have no idea how their exact age is within 1%. I know they are 40, they're 44 or 45, and 2%, who cares? But the universe is probably my most accurate acquaintance at the moment.
I often like to tell my introductory students, they say, what's the point of taking astronomy? Aside from fulfilling your general education requirement, the actual value of astronomy is very intangible, just as Janna was saying. But I like to say that it won't change the price of bread today, but it could change the course of civilization tomorrow. And cosmology may be, as Piet said, perhaps the most abstract and most grand of those things that can change civilization tomorrow. What kinds of things do we have to think about when we know the age of the universe more accurately than we know the age of our friend sitting next to us? It's a remarkable shift in how we have to think about things. I would love to get in later on to concepts about the beauty of the universe. How beautiful is the cosmological constant? Things like that, which are odd but interesting questions to ask. But I would like to, by passing it to Professor Du, tell a story and perhaps ask him to respond as well as you all later on. You see, I was delighted when I saw that Professor Du was going to be in this panel with us. I, years ago, as a ruddy-faced college freshman, took a class with him, one of hundreds of anonymous, faceless, ruddy-faced freshmen, in a course about ancient civilizations and China. And I remember him giving very fascinating lectures to me about Buddhism, about what Confucian ideals were and so forth. And it impacted me quite unexpectedly last summer. See, my mother had brought her older brother and his wife to the United States for a few weeks to come visit. Naturally, it was only appropriate that I take them to the Rose Center for Earth and Space and show them the Hayden Planetarium. And as we were walking through, I of course was explained to them, I was speaking Mandarin Chinese and a little bit of Hakka as we were sprinkling through and saying, well, this is the nature of this expression explains what the universe is and so forth. There is an exhibit display which shows the entire 13.7 plus or minus 0.2 billion year history of the universe. It's a pathway that spirals down from the big Hayden Planetarium sphere. It's about 350 feet long, and every inch represents millions of years of the history of the universe. And I was walking and explaining to my relatives in Chinese, well, this many billions of years ago, this is what happened. This many billions of years ago, this is what happened. And I noticed that there were several people walking behind me who were also Chinese. Now this often happens, actually. Anytime somebody is walking around in a museum and looks like he knows what he's talking about, a small commentary tale forms, some imagination that this person actually has a clue about what's happening. But as I was walking, and I was down to about 10 billion years or so after the Big Bang, and the gentleman, about the age of my uncle, came down and said, "Hi, I just wanted to let you know," in Chinese, speaking in Chinese, that this is very interesting, but it's all incorrect. And I said, "Oh, really?" He said, "Yes." And I don't remember exactly what he said at this point. It became a blur because it kind of went outside my normal cognitive thought in the universe. He said, "Well, you see, the great and mighty Buddha has decreed that this is actually the 6th incarnation of the universe. It's not 13 billion years old. It's more like 170 billion. And it has happened 5 times before. The great power of the Buddha has created a cyclical cosmos, and we just happen to be aware of this only one." And he went on, and I don't even remember what the numbers were. The numbers I said are probably incorrect, but it was roughly of that nature. And I was like, wow, that's really something. And I tried to listen. He kept going and going for several minutes. But I was trying to absorb it, and not in a sort of closed fashion, you're wrong, go away kind of thing, but in sort of saying, what motivated this gentleman to feel that he was more comfortable with that kind of cosmology, that kind of the universal structure, than that which is displayed here in this building, which he can touch and is tangible and has been brought down over years, decades of scientific work. So this is something that I hope that Professor Du can address to some extent over the course of the next hour. It doesn't have to be immediately, but... So.
I certainly am not in a position to defend your Chinese friend's challenge to modern cosmology. He may very well be right. There are a lot of incarnations even in cosmology. But that's, of course, his own belief. But I'm a little bit worried when a moderator talked about the Dark Age and the beginning of the 17th century, the Enlightenment, and of course now, in the last 10 or 15 years, we have totally radically different conception of the cosmos. Because what I've been doing for a long, long time is really working on the Dark Age. And also I find that the Dark Age itself is something that may become very relevant to many of the problems and issues we'll be exploring here. And this reminds me that about 10 years ago, Piet and I spent about a week in Dharamsala and engaged in a 5-hour per day conversation with the Dalai Lama for 5 days. Originally, I thought these eminent scientists, the 5 leading physicists, were there simply to educate the Dalai Lama about the modern universe. But what I really learned in that conversation, it's a really fascinating dialogue between science and religion, both in a very broadly conceptualized way. So I will begin with the notion of the so-called axial age civilizations. This is a notion that the German philosopher Karl Jaspers used after the Second World War. And Jaspers conceptualized human history in terms of some of the great spiritual civilizations in South India, in South Asia, such as Hinduism and Buddhism, in East Asia, Confucianism and Taoism, in the Middle East, Judaism evolved into Christianity and, of course, Islam. So these were civilizations, from his point of view, after the Second World War, still very relevant to our conceptualization of our world, and especially our personal experience. And then he identified 4 what he called paradigmatic personalities: Socrates, Confucius, Buddha, Jesus. Of course, now the list will have to include Muhammad and maybe Lao Tzu and other people. So the question that I have with this new vision of the world, and we're going to have a radical new conception of the cosmos, and all these people for centuries considered wise voices, or the wisdom of the elders, are they totally relegated to the background? Or there's something that the communication between enlightened modern scientific thinking and some of these cumulative wisdom is still very much a part of our own universe. I simply want to know one thing, though. The Enlightenment since the 17th century has been so powerful. There's also an underlying assumption. The more we know, the light source will shine forth, the darkness will be expelled. So the notion, almost like the evolution from the superstition of religion to metaphysical reflection, now we're in the age of science and experimentation. We know for sure what's going on. So the assumption is that our knowledge extends, our darkness and ignorance will be reduced. But I think most of us now agree that the more we know, the more we are hungry to know more, the more we become aware of how little we really know. The more we try to find this, like Leibniz trying to find the monad, that small thing that will help us to construct the universe. The more we try to look for that, the assumption then is, if it is small, then it can be simple. And the simpler you get, the more basic you will get to the material reality of things. But now we know if it is small, it doesn't mean that it's simple. It can turn out to be extremely complex. So we have a situation where the more we know, the more we are aware of our vague ignorance is extended more. So in this particular situation, I think it is not at all unusual for some scientists, like my colleague Gingrich, to talk about God's universe, right? And asking these kind of issues. So I think part of the conversation maybe should be also a continuous dialogue between the most advanced understanding of cosmology on the one hand and some of these other forms of knowledge. Hilary Putnam once characterized some of these forms of knowledge as non-scientific, but it doesn't mean they're not meaningful, important, and absolutely transformative. Now, how do we deal with something which is not quantifiable, which is often intangible, which may be extremely elusive or ineffable, and yet profoundly meaningful, not for just our daily experience, but for our understanding of the universe, our understanding especially our own planet. I will end with one short note. Probably in December 1968, for the first time, the human naked eye is able to see our planet Earth, which is, of course, much smaller than the expansiveness of the cosmos. And for the first time, we realize how vulnerable this particular habitat of the humans is. Not just the minerals, the soil, water, even air. And that awareness, I think it's very difficult for us to imagine. To me, it's just as fundamental as some of the great scientific discoveries since the 17th century. Because before then, I think maybe Wittgenstein made a remark, if you haven't died, you never know the meaning of life. You have never left the earth, you never know the meaning of the earth. Now, in a strange way, thanks to great science and technology, we managed to get out of the world and look at it. And we, even for high school students, or primary school students for that matter, we have a vision that totally unimaginable before the 60s, let alone the earlier period. And that certainly helped us to change the world, change our understanding of our Earth and so forth. Maybe what happened in the last 10 years or so, this incredible discovery of the cosmos will also, through certain kind of trickling down process, will help us to reconceptualize not only our relationship to the cosmos, but the human relationships, our relationship to our own planet, and our relationship also to history, to some of the great minds in the past.
So let me speak for myself now. Now, I agree with some of the remarks that Professor Tu made here. Now, one thing I have to make sure that I'm not misspoken. When I refer to the Dark Ages, I was referring to the kind of Western type of thing. I was not referring to the, just to make sure, that's what I have in my mind. And there I stand by my statement. Now, secondly, I believe that we may have, I will use a cliché now, a paradigm shift in our thinking about how we think about science. Because you see, I don't buy this thing that we have it for many, many years now, and especially with the postmodern philosophers and stuff like that, we have this attack on science. That scientists, they keep changing their minds. They, from one Monday morning, they change, they say the universe is doing this, the other morning is doing that, and stuff like that. I think we have, maybe some of this thing was correct, but that was through, the 18th century, you start all this business, it takes time to understand things better and to reach some conclusions. Now, we have to put in our minds the following thing. We're getting now photographs or ways, in quotation mark, of the universe as it was 380,000 years after its appearance. That's the word I like to have, neither origin or appearance, because we don't know even if it was an origin. Now, its appearance. Now, And eventually, I think within the next, I don't know, maybe 50, 100 years or something like that, we'll be more clever and have a little bit either closer to the beginning of the universe. Now, why I'm saying this? This is irrefutable evidence there of what it is happening and the corresponding theories that is going to support this thing. Now, these things are not going to change. Like when we go now and we go to the inside the matter, we have quantum physics, right, for this thing, which is almost now 100 years old. We all using it, in our house every day. Everything we're doing basically is based on quantum mechanics. It is strange to us, it is strange even to the scientists for this thing. The universe is based finally, because the universe is expanding. That means in the very beginning it has to be very, very small, even smaller than an atom or whatever it is, for this thing you can say. So it has to obey these quantum rules, right, for this thing. So that brings us the idea of the probability and the chance for this thing, how all this thing has been appeared for these kind of things. But we have, and that's why I would like to stress, we have experimental and observational evidence. And this is now, when my friend here, he was talking about 1%. When I was a student, they didn't even know, what it was about. I mean, they didn't even want to quote numbers. Then we went to this 10 billion to the 15 billion years. Now we go to 1% and other quantities too. And that means that now cosmology has become precise part of the scientific community now, and is going to have a lot of answers. Is a lot of the problems that we were facing for thousands of years now for this thing. Now, this will be the scientific answer for this thing. This, of course, has been addressed now, to see how now is the communication is going to be with sociologists, psychologists, philosophers, and I believe that a new kind will come out of this, where everybody is going to participate. I'm not saying that the scientist is going to do. The scientists are going to do what they're supposed to do, right, for this thing. But the only thing that I'm getting a little bit upset is this kind of thing that scientists, they keep changing their minds every Monday morning, right, for this thing. I don't think we're changing our minds every Monday morning, right, for this thing. I think things are being settled now, and it took years and years and years and years, and that's it's right, because that's it's an evolutionary process, how we learn things and stuff like that. We have the technology now, and we have these things, so that's why all of these things is happening at this moment. Of course, we're sitting on the shoulders of giants, and the next generation is going to do the same thing, and so on, but already we have on this table things that are going to change our view about the universe. That's what I like to stress for this thing. And it is not one of the same kind of things. And as Janna said, we know even today, as of this moment, that not only we are not the center of the universe, which we knew from Copernicus, but we know also that we are not made from the same stuff that most of the universe is made. And now we know that 73% of the universe, of the energy balance of the universe, is pure energy. It's not even matter with the definition that the scientists are giving to this thing. And from this 27%, 24% or 23%, it is what we call dark matter. Here's a photograph over there, a picture there, right, for this kind of thing. And we are only made protons and neutrons and electrons, whatever you learn in high school and kindergarten now. It is the 4% about. We are made only for the 4% of the whole universe is made of. Now what we're talking about, right, for this thing, all of these things has to come down, and we have to absorb all of this stuff, and this is experimental observational stuff. Doesn't matter if we does not have on this table an acceptable by everybody theoretical explanation for this thing. This will come with time, right, for this thing. But definitely all of this thing is going to change our views about the whole structure of the universe.
Well, I really agree with you. There is this idea, and I've heard it a lot in discussion, that science is this totally relative thing, that eventually we change our minds and everything. And no, Newton was totally wrong. It's not like that at all. Obviously, we are never going to go back to the day when we think that the sun revolves around the Earth. That is never going to happen. We really don't backtrack. We know when we're along a road. I mean, even that the universe is accelerating, we know we're in a touchy time, and that we're going to know a lot more in 10 years than we know now. And we might have to backtrack on some of the things we're saying today, but we're aware of that. We know the difference, I think, between stuff that is really solid and stuff that is still the stuff that is still being developed. And so I really very much agree with that. But I think it's an interesting question when you bring up the great minds of previous centuries, to say, these are brilliant people who are as framed by their context as anybody. Maybe they're more visionary, maybe they see ahead, but they're also framed by their religion, by their culture, and by the state of science at the time. And I think it's interesting to wonder how their minds would have been different, how their teachings would have been different in a different culture, in a different bed of knowledge. I was recently reading some quote from Abraham Lincoln, who was an extremely progressive, enlightened human being and truly a fascinating person, but this was an incredibly racist quote. It's not that he was a horrible racist, it's that it was a racist time. And he was a product of that time. Had he been alive today, he never, we imagine, would have dreamt of saying some of the things he said in this quote. So we are very much shaped by the things we know at the time, even the great minds. And so I think this is part of what we say, how it changes us. I think it's fascinating to wonder how it sloshes back and forth. How will science change culture? How would these great minds that are not scientists, how are they changed by the climate of what we know when we know it? And I think more and more, it's like you said, we know the job that we're doing. We're measuring things, we're making theories. We have our part to play in that. Our part to play is not to necessarily make huge sort of cultural declarations. We do what we do regardless, in a way, of whose sensibilities it might have been, including our own. And I think that is something that's really interesting. You described Einstein not wanting to believe that the universe was expanding and that it had a beginning, or at least it was not infinite and static. And this was horrible to him, and he went so far as to change his own theory. And that's a beautiful example of where one person's cultural notion interfered with their scientific vision, and he calls it his greatest blunder. Not because it was the biggest mistake he ever made. He was not the greatest mathematician. He often made mistakes. His greatest blunder was one of belief in some way. And I personally think that's why he called it that. And I think one of the beautiful things for me, why I was drawn to science, was precisely because I have to change my belief system when confronted with certain data. I might believe that 70% of the universe is dark matter, or dark energy rather, but if an experiment comes along that's different, I'm happily change my mind. I feel the same way about, psychic powers or telekinesis. If somebody would just show it to me once, I will happily change my mind. So, your belief system in science is beautifully unimportant. There's something about that I find very gratifying personally.
Now we're discussing.
I think we should make a distinction between progress and progressivism as an ideology, as a belief. There's no question about the progress in science. And the more we know, and we verify things, we move ahead. We don't make the same mistakes people made before. But that's true in many other areas as well. Now, sociologists used to have rather limited understanding how society works. As they become more progressive in their thinking, they will be able to do that. But progressivism is the belief very deeply rooted in the Enlightenment. I think perhaps the most powerful ideology in human history is the Enlightenment mentality. I use the term mentality very advisedly. It's not the Enlightenment movement. It's not what Habermas and others say, the Enlightenment project that still needs to be realized. It's a particular mentality, especially in China, because it's not science, it's scientism. It's the belief that social engineering, it's the belief that we know the engineers, not actually scientists in terms of basic research, but the engineers, this technocratic mind that we know what's going on, and in fact we are now in this age of enlightenment. Anyone who still believes in something like religion, or a Christian, or a Jew, or Buddhist, there must be something wrong with them. There's this insensitivity to many other areas of human concern. Why in an advanced course in philosophy at some of the leading universities, and these most brilliant minds together with the teacher try to struggle to understand Plato, 2 or 3 lines sometimes, or Socrates, or for that matter, study Sanskrit text in order to understand Buddhist idea. That kind of cumulative wisdom, it's also a form of understanding. If we believe that when we move, with the progress of science, all the other domains of human experience, human wisdom will naturally follow. That's not the case. I think sometimes we have this incredible problem of educated incapacity. The more we know, the more we focus on what we know, the more narrowly professional we become, the less we're able to understand other dimensions of human experience. That's just as
I in no way find them at all mutually exclusive. I find that even surprising that it would be on the table, that the idea that by looking at, let's say, cosmology, which is the topic for today, in a scientific way, that it would somehow exclude the study of Sanskrit lines or the importance, the humanistic importance of literature or art. Quite the opposite. And I do a lot of dealings with art precisely because I think that that's profoundly
then I will.
Sorry, am I hogging?
No, you're doing fine, perfect. Please, and then I say
a free discussion.
That's exactly right. Yes. If you have a point on a specific issue, you make immediately. Yes.
There are many things I would love to respond to in what you said, but just to, for example, the fact that ethics and aesthetics is still completely outside science, and it's one of the most important areas in our life on a daily basis. So that already is not part of science, and whether it will become part of science in a very long future, who knows. But what I would like to focus on is, in science itself, how young science is. Science got started in the modern form, say with Galileo, only 400 years ago. And the oldest expressions of art, the oldest expressions of depicting something outside ourselves, are in cave paintings of 40,000 years ago. So again, we have the 1% that for 99% of human history there was art and religion, and only the last 1% there is science. So science often sounds like a teenager, like an adolescent, rebellious and arrogant. And
that's fine.
But it's because it's so young. And in another 400 years, when if we could speak again, I think science will shape up quite a bit in its social.
So we can be forgiven for.
And also, and also, you see, on this relation between science, you see, the thing that really bothers a lot of scientists, I guess, it is in relation with the society, that you see, a lot of people. I mean, read today's literally New York Times or something on what happened in Texas. Some statements there, what is happening today, of 17th of February 2007. That you real suicide. Now, what I'm referring to is the following thing: that it is people are building their lives on some beliefs that has been transcended from them for the last 2,000, 3,000, I don't know how many years. Again, I'm speaking about Western societies, which I have a lot of experience. Now, for this, Eastern may be worse. Sorry?
Eastern societies may be worse.
Now in China.
I speak about experience that I have seen in my neighborhoods. Now, and then you see people, because of these beliefs, that they spend their lives for this thing, in a ways that you really cannot believe it, that in 2007 or 2000 or something like that, these things will happening, for this thing. And I believe that is the whole society, something very wrong is happening. And that's why I believe science, beyond all the spin-offs about the applications that you go to a doctor and you use always, these new instruments and stuff like that, which I'm not referring to this kind of thing, even to the stuff that, conceptually, we can change a little bit the way that we're looking at the world, that will be better, right? And I agree completely with you when you were saying that, there's much more there than religion, to make religion to be the whole opposite or complementary to science. There's so much other stuff there that we can combine together in a satisfactory way.
Can I add one more thing?
Please.
Yeah, then it should be your turn. So
please cut in and don't.
Sure.
So we know each other too well. We can't be mean to each other. Yeah.
So the idea of science being so young, I think the most interesting aspect of that, concretely speaking, is that science wants to be empirical. It is based on experience, on experiments in the laboratory, experience using a telescope. So that is science's greatest pride. But if you actually look what has happened, every time I have an experience, you can see it already in a language, I see a table. There is a subject, there is an object, there is an interaction. And every everyday experience is like that, every scientific experience is like that. But science started by taking the easy part. It focused on the object pole of experience. It did not want to say much about the subject pole, it did not want to say much about the interaction, but if different subjects in different ways agree on the same object pole, then that is something which we say, this is empirical. This is really what empirical methods have established. And that was a great way to get started. And in 400 years we have had an enormous, we have been able to build up an enormous body of knowledge about objects. But still, if you go back at the source, where does empirical methods come from? We still have had only this one pole of experience. We still have very little to say about the subject pole, very little to say about what experience is, what conscious experience is. And the hope is that by studying brains, like what you have been involved in, that would be one inroad. So the hope, the unwritten hope in science is that by taking empirical method, taking only one pole, if studying that in great detail, you can go back to the back door, to the pole door, into the rest of the empirical attitude and try and reconstruct everything. But that is at the moment an hypothesis. It may or may not be true. It may not even be clear whether or not we can find a criterion to say that that is true, but it is at least the attitude at the moment.
Yes.
But while scientists will continue doing that, I think there is room for philosophers and people in from other ways of knowing, certainly also psychology. I mean, we are here in a psychology building. It will be interesting to try other approaches as well. So scientists will do what they will do, and they will try not to be affected by their contextual situation, which is a good thing. But so my prediction for science will be that in the next few hundred years, probably there will be a much better understanding of the subject pole of experience. And we have seen in quantum mechanics that the way you measure something already influences what there actually is in matter. It's a very surprising thing. We have neuroscience, where you translate subjective and objective experience effectively. We have robotics. Robotics is a very interesting thing, where basically we make a tool which is a subject, not an object. If you go 50 years ago and you read science fiction stories of 50 years ago, everybody predicted that there would be robots in every household. Nobody predicted computers in every household.
That's right.
But a computer is an object and a robot is a subject. And we have 100,000 years at least experiences building objects. We have only a few decades experiences building subjects. This is also why software is such a problem. Hardware we can make, but software, it acts like a subject. So I think in the next few hundred years, science will grow into the whole empirical realm, talking about consciousness as well as subject as well as object. And the current world, the current scientific world picture is a picture of only objects. And often when I reflect on that, I feel like the person who for the first time went to the moon and looked back at the Earth. In a way, if you become aware of the fact that you are not only an object, but that you're really qualitatively something different, at least in your own experience as a subject, then if you look at the scientific world picture, it looks like you're looking at the world at arm's length. Since we are so used to identify, especially young people, to identify ourselves with our brain, with our hormones, with all the objective constituents in our body. And we forget that in the most direct empirical way, what is given here for each of us, what is given here in this room, everything you see is being painted in your experience, in your consciousness. And that is the first tool you use to study everything else. It is like a blind man who uses a stick to walk around, and with his stick he can feel the whole room. But if you ask what is he really feeling, it's only the stick and the vibrations in the stick. So yes, we have a very good scientific, objective, empirical method. But everything we are experiencing is given in our experience. That is our stick, and in that sense we are blind, and yet we can understand a lot of what is going around us.
What I'm starting to hear here is a confusion between scientific knowledge and unscientific knowledge. Piet, you're talking about what we would consider as consciousness, which we're just beginning to understand the science of. Seeing things which are empirical, which Galileo, as you rightly pointed out, defined as being empirical and scientific. But you know, the schism between non-scientific and scientific information came with Galileo when he basically wrote, I wish I remember the actual work that he wrote this in, but when he's declared that he could no longer say whether or not it was beautiful that a falling object falls, right? And because he could not relate the two, he said, I'm just going to deal with the empirical now. I'm going to let other people deal with the philosophy of beauty and aesthetics and so forth. And over the past 400 years, things have split so far that we no longer remember which is which. The intelligent design controversy is precisely this. I deal with this all the time in introductory astronomy classes. You know, well, how do we know that the universe was a Big Bang thing? Couldn't have just some flying monster reached his tendrils down and created the universe? And I said, sure, no problem. But what's the difference in between these two knowledges? Each one has value. But which one do we consider science? It's the one that we have made predictions about the hypothesis that have been confirmed. The hypothesis which has not been confirmed is not scientific knowledge, but it could be just as valuable. And so perhaps, Professor Du, we are coming back to the place now where it is appropriate to start knitting together that knowledge which is scientific and that which is non-scientific, valuing them roughly equally, which has not been the case in the past century of our civilization. And in that case, gaining some greater understanding. Nowhere in science, anyway, do I see that linking together more beautifully than in cosmology.
Yeah.
Where forever, humans have always wondered where did we come from.
Right.
Now, in the past few centuries, we've figured out where we come from, but we really haven't. From the actual consciousness, scientific point of view, we still don't know whether or not the cosmological constant is beautiful. And I'd come back to this, as I said earlier, because when we were putting the Rose Center together back 1999, Piet, you probably remember some of these conversations. In 1999 or so, that was just around the time that this dark energy thing was starting to be confirmed, with the various observations of Cepheid variables locally, and also the cosmic microwave background having its sorts of things, supernova cosmology changing. And cosmological constant became important in all our cosmological ideas scientifically. But we had to put this cosmic pathway together to say how old the universe was as time went on. So to figure the age of the universe, we needed to know what cosmology we wanted to use. How much was dark matter, how much was dark energy, how much was real matter. And we had to send an email out to our scientific advisory committee saying, folks, we need to make a decision now about how old the universe is so we can put it in this stainless steel pathway.
What do we use?
Yeah, what do we use? What are we going to say? And I actually, from my observer's perspective, I'd said, you know what, let's make the age about 13.5 billion, but let's leave the cosmological constant out because it's kind of ugly. Sticking that thing in there makes our conception of the world not the beautiful matter-only thing, that space is uncontaminated with this extra stuff which shows up just because space is there. And Mark Kamiukowski, a very, very brilliant cosmologist, sent back an email almost immediately saying, no, bad call, bad call. As aesthetically and theoretically abhorrent as I find the cosmological constant to be, that is what the observations say, and thus it must be there. So, is the universe now uglier because it's got this extra contaminant in the beautiful pristineness of space? I can't answer that. but perhaps...
How is the contamination if it is 70%?
I was just saying, we're the contamination.
We are the contamination.
I agree. You see,
We're the bit of
nothing
grit.
there.
That's right. We're the junk that causes
the
space-time
fly
to
in the-
bend.
I mean,
it's our fault.
yeah, I mean,
but that's isn't
the-
that a shift? Isn't that a shift?
Yeah, the
in our-
contamination. We zin in the contamination.
Yeah,
That's
right.
right.
But presumably, you know, with
the
the
73% guys. I mean,
Yeah.
we are the 4% and less. You
We're
know.
the ash.
But remember,
We're the
8
ash
years
left
ago,
over.
that was still not 100% certain. We weren't clear yet.
I'm still not sure it is 100% certain. I mean, I
That's a
think
good
we could
point.
argue about whether or not it's
For the
100%
cosmological,
certain
but
now.
anyway, we get them technical now. Even the word cosmological constant don't want to call because we don't know if it's a cosmological constant. But okay, when
We can't, yeah.
Can you explain that?
Yeah, what do you think it's not beautiful?
Well,
yeah, I don't understand. This one I don't understand.
There's
About
a-
the beauty of the cosmological constant, I don't understand. But
Who do you want to try the
Yeah,
cosmological
well,
constant?
go ahead.
What
is the constant?
Do you want to try?
The cosmological constant is just a little bit of energy that exists in every cubic foot of space. Space is not nothing. You can basically...
It's basically the energy of the vacuum. Usually you imagine if you took a vacuum, you mean literally a vacuum, you evacuated everything inside
Platonic
it.
vacuum.
All the atoms, everything you could possibly think of to get out of there, all the light, everything. So it was just as dark, as far as you could tell, totally empty vacuum. It turns out that in Einstein's theory of Einstein's general theory of relativity, that could have an energy associated with it, even though it's empty. It's totally empty, no particles, and as far as we know, no normal forms of energy. But according to the general theory of relativity, that might actually have an energy associated with it, and that energy we've become accustomed to calling the cosmological constant because it was the term introduced as Piet was discussing that Einstein introduced to try to render the universe static. He introduced this term. It was called a cosmological constant. So that's the terminology we carry on. But what it really means is the energy of empty space. Is that a fair description?
Perfect.
And it originally emerged as a way for Einstein to defend his...
That's right. It was simply a mathematical term that he stuck into his equations. His equations, somebody told him, do you realize your equations predict that the universe is expanding? So someone just took them and calculated some things and said, oh, this predicts the universe is expanding. Einstein refused to believe it, so he literally stuck a term in. It was the only possible term he could stick in that were consistent with things like causality and basic, certain essential, simple principles that he originally didn't introduce because he thought it was ugly.
Right, and there was no physical reason to put it
think
in
it would be
there.
there.
It was purely only for aesthetic purposes. That's why it's ugly.
And just to make the picture clear, you had the original explosion. Space expands very rapidly. Then space slows down because of the gravity. Everything attracts each other. So you have this fast expansion, then it slows down. But then while it is slowing down, more and more space is created. It is not, and that is often hard to imagine, the Big Bang is not an explosion within space,
right,
like when we create an explosion, but it is an explosion of space. Space is created in the Big Bang, and probably time also, so it may not make sense to say what was there before the Big Bang, because time and space, as far as we know, were created in the Big Bang. They occurred, they appeared. These are dangerous words to use, loaded words. So there was the origin of space and time that expanded, and then while the Big Bang while the universe was slowing down, with the possibility of maybe falling back again, while it was slowing down, it was still expanding, but with more and more space appearing, the energy in the space appearing, they turned out to be repulsive. So after a while, the slowing down stopped, and the speed remained constant, and then started to expand faster. So you have this very complicated situation of the very fast expansion, the slowing down of the expansion, and then the increasing speed of the expansion. We are now in an accelerating phase. And whether in the future it again will slow down and maybe fall back or not, nobody knows. It depends. Maybe there is another contribution to the cosmological constant. Maybe the constant is not quite constant. There are still many open questions.
And the
fall
argument
back, I don't know, because we know about the energy density, so we know that it's going to be open or flat. So to coming back, I don't think we have to. The closed universe, I don't think it is possibility. But never mind. That's okay.
Let me offer the ignorant point. Okay, and sometimes if beauty is understood in terms of a static structure, let's say geometric form, everything's predictable. You can see it. You can see that's very appealing. That's the pristine picture of something that is beautiful. But if we also associate beauty with a dynamic process, it's not just static structure, it's a dynamic process. And the dynamic process involves unpredictability, involves fuzzy areas, involves chaotic situations you cannot control. And in fact, from the Chinese aesthetic point of view, that's really the most marvelous thing for a creator. For example, a calligrapher who's going to develop a vision about his own understanding of the world. And the ability to show the dynamic change in the process and the unpredictability of how he's going to finish it. Sometimes, imagination, all these other features become part of it. And so it becomes aesthetic or aesthetically appealing precisely because it has violated our rather conventional knowledge about what is pristine, what is clear, what is precise, or what is a static structure.
This is perfect with modern cosmology now. What do you this kind
So the
of
universe is becoming more beautiful.
That's right. That's
as
what
it becomes increasingly complex.
No, I think more beautiful in the following sense. It challenges our rather limited conceptions about what's going on.
I think also, just I know you're about to open up, but I think what you say is really interesting because we have to remember that, of course, this scientific endeavor is a human process. And what you say about separating object and subject, I think, is very relevant because we're in a time where we've made a kind of cultural agreement to study the object, but we are asking questions that we find important for human reasons.
Right.
Why is it interesting to me that the universe had an origin? These are human questions, and I think that shapes the flow of science. And as we respond to that, we were both discussing before the panel started that we study chaos and complexity, and that is a shift,
yes.
Especially in fundamental physics. So I think these things are relevant.
This reminds me.
Nice.
Yeah, just one short note. I think this a great thinker, and also very much involved in the whole question of ecology, Thomas Berry. He's made the following observation. He said, for years and years, we just assume the world outside is a collection of objects. These are collection objects. We look at them, study them. But he said, is it possible for us also to imagine these are the nature out there is not a collection of objects, but it's the possibility of a communion of subjects. Now, on the surface, the notion is totally unscientific. If we follow Piet's notion about the importance of not just the subjective, the inner process of human understanding, that kind of interaction, it's an attitudinal question. It's not whether you are scientific or not scientific. It is how you consider your own scientific work in the broader context of the human context. So in that sense, even the idea of relating to the cosmos, as you describe it, as a communion of subjects, is not simply non-scientific utterance. It has some deeper meaning of how we relate it. I remember quite a number of years ago, a group of scientists, Carl Sagan was involved in that, and sent a letter to religious leaders and arguing it is very important for these religious leaders to begin to appreciate cosmos, appreciate the world as sacred, because the scientists discover the beauty and dynamism and importance. So these spiritual leaders would try to teach a lot of people how to appreciate the whole cosmos and how to appreciate nature as sacred. And that, in fact, is because they believe that many of the religious leaders, not at all seasoned in scientific inquiry, become wired in their attacking science, and therefore people develop totally unrealistic view about nature and so forth.
I think it is, in scientific terms, you can talk about it as a choice of coordinate systems. Mm-hmm. We find ourselves empirically in a situation where we are part of this world, and the world is given to us in consciousness. So there is a mind-world circle. That is the empirical basis, and from that we conclude that the most reasonable way of of sharing all our knowledge, and the most reasonable way of organizing our knowledge is to say that there is a world in which we appear and we have knowledge of the world. But purely empirically, we start in the mind-world circle, and just like the map of the Earth can never, if you make a map of the Earth, you can never make it precise. It depends on the projection you use. We generally take the materialistic or realistic, as it's called, projection of the world, rather than an idealist projection or different types of projections. But we have to remember that we are talking about particular coordinate systems.
Mm-hmm. Maybe it's time to open a little bit the discussion for this with the audience, and maybe we come back for this thing. Now, you were first. I saw your hand there. And please, if you have a address the person that you are referring to, or leave it, for all of us. It doesn't matter. It has to be specific, but please go on.
Okay, well, to put myself in context, first of all, I'm an atheist, indoctrinated as an atheist from childhood. But I'm
Is it possible to indoctrinate atheism?
Absolutely.
I learned something.
I'm not a creationist in any sense of the word. However, the Confucianist among you is the man who resonates most with me in this conversation. And to start with, the notion of beauty, as far as I'm concerned, has nothing to do with science, the scientific approach. It's art, it's the preoccupation of the subject. And I'm glad that you brought the subject-object issue onto the table. But even, and especially quantum theory, confirms that the subject informs the observation as much as the object that is being observed. Therefore, I find any conclusive attitude among the physics community unacceptable to me on scientific terms.
Conclusions about what? Conclusions about beauty? Conclusions about
no, not about beauty. Everyone's entitled to their conclusions about beauty. That's private and subjective.
You want to say that the scientific evidence that we provide somehow is random, or because of this quantum mechanics stuff, you say?
I'm not denying that the scientific community has accumulated gobs and gobs of observational information in the last 400 years.
Yeah.
However, that information nevertheless is being observed through a subjective lens. Therefore, my opinion is that the physics community needs to recognize, no matter how much it observes, that it is starting from a subjective place.
Okay, now shall I?
Go ahead.
Because I'm very keen on this.
You have pushed
to be
his
hard
buttons.
now.
Sensitive.
I would like to express the following, because it sounds to me, I'm glad that you said in the beginning, because otherwise it would be harder. Now, when you saw where you're coming from, now, and I have nothing against it, on the contrary. Now, because it sounds to me a little bit like this relativism and stuff like that. And let me come to this, because quantum theory is so much misused, so much misplaced, so much abused, for people that they have nothing to do with science. You see, there are people that are hearing their certainty principle, and then they say, like this relativist, I don't mean the Einstein, I mean this philosopher.
Oh, relativity theory was
and
also
then you say,
misused.
there are certain principles. So there's a certain principle. So what these guys are talking about, we never go to know. No. There is what these great holy fathers, because that's the real holy fathers, Heisenberg and Bohr and Schrödinger, etc., they were told us about. It is that we are caricatures of reality, that the fundamental laws in physics, it is the physics of the microstructures. We are, I repeat again, classical structures, and because we are classical objects, we are built in us these notions that we would like to know if the electron goes from here to here and has this, like the bus outside from Madison Avenue and stuff like that. This is wrong conception. The real world, it is the world of particle physics, right, for this thing. We know this is the fundamental notion, and that tells us about the way that this thing is working. It looks very strange to us, and we introduce the notion of probability and chance, but there are equations that these things are telling us. That means if you have an electron and he does from here to here, there are probabilities, and if you ask me, I cannot answer you questions that we as a classical object ask, and because this is wrong questions. But the thing of notion of science is, if you give me 100 electrons in one specific state, anytime we give me this specific state, I can give you probabilities what they're going to do within the next few seconds or something like that. And you are going to find anytime you put these 100 electrons together, the probabilities are going to be the same. So you see, the notion of this classical notion of the world static kind of thing, it has been changed, but that's the way that nature is working. So it is not true that this uncertainty principle and all of these things have destroyed the way that we understand the world, that we cannot predict things and stuff like that. The language has changed, and we have gone much inside the reality of the thing, and that's how this thing is working. So this notion that somehow, because of quantum mechanics, we don't know what we're doing is very, very wrong notion. And I'm not talking to you, I mean, you know, for this kind of thing, but this is how it passed. Because if you go to every bookshop around here, you know, for this thing, I think you should be in prison, you know, what they put out these books about all this quantum, and just go and just go through this to see, and I become red in the face. You know, for this. I don't know how they allow these things to go in the public, right, for this such kind of misuse. So what I'm saying, I would like to conclude with this thing is that quantum physics, and I repeat again because I see it all the time, I see it in newspapers and I see it in everywhere, is the most strong notion that we have about this. This is as good science as everything else, and it is as predictive as everything else. The only thing is that it is not immediately understood by us if you're not inside to this kind of thing, because, I repeat, that's the only thing I would like to keep in your mind. We are classical objects ourselves, right? For classical objects, that what we in classical physics, right? For this kind of thing.
To the extent that we are objects, we are classical.
Right, for this kind of thing. We're macro objects, and that's why we have a very different notion for this thing. But we know that the real thing, it is on, there's a very difference on the particle physics. If you were in electron, you would think much differently. Sorry. Yes.
I was glad to hear the conversation about the subjective and objective polarities, rather than a kind of sharp demarcation between the inner and outer life. And I think one could argue that there's a kind of continuum from a sheet of pages, let's say, from the core self to the diversity of the world, as the inner life and the outer world gradually become more and more articulate. So my question is, as a kind of subjectivist way of thinking about the world, my question is to any of you, because I'm not sure what modern cosmology is after this conversation. I still don't know exactly. I've heard a lot about beauty and other things, but I'm not really sure what the new cosmology is. What I'd like to know is whether you think there are any regularities or laws of nature that can inform our concepts of psychology. For example, in the early 1900s, Whitehead's way of thinking in terms of a process of metaphysics informed psychology. And so the notion of the subjective and objective pull and compressance and actualization and so on are important concepts in process theory. So I'm wondering what the modern cosmologists would have to say to that kind of approach and what we can learn. I mean, Whitehead took metaphysics and tried to develop psychology. Some of you are looking to cognitive science for maybe computational mechanistic approaches to the nature of the mind and expect they are going to interface with laws of physics. And I'm not sure that kind of static mechanistic approach is going to work. So I'd just like to know what your comments might be about subject-object process ways of
Let me make a 30-second point about this and then let my colleagues answer this. The large-scale structure of the universe, the way that dark matter and matter are distributed, is not exactly uniform on small scales. Rather, it actually, the filaments and the web and the structure is very similar to a fractal pattern. Mathematically, it follows fractal patterns. And neuroscientist colleagues of mine tell me that the way that human neurons are put together, when you look at how the dendrites and the axons and so forth and mathematically describe their structure, they also follow a fractal pattern. So from cosmology down to the human brain, there actually is a structural, objective similarity in that one respect. Right. And so that's where I want to leave my buds here. I mean, to talk about it.
Let's develop. Now, do I hear here that what you're saying is there is in this map? I think we were together in the mind soul thing, right? If I'm right.
They invited you back, but not.
Okay. But in this one. Now, what I'm saying here is, do you like to say, because you say about physics and stuff like that, I mean, do you want to say that beyond brain, you know, what we have here, this 1.3 kilograms, whatever it is for this thing, there is something, I mean, and that everything comes from there, there is something else there?
No, I would be as reductionist as anyone.
Just to, because I know that.
But you can't just simply eliminate problems of mind and simply say, and put them in the hands of future neuroscientists and say, well, neuroscience is going to solve that problem in 50 or 100 years. I think you need to deal with the problems of cognition, the nature of an active thought or an active cognition. What is a mental state, for example?
Sure.
And I think it's cyclical and there's constant replacement of mental states. So I wonder whether there's any cosmological principles, for example, that might map on to that kind of
I don't think I'm going to say anything that's going to be satisfying for you, but just two random things that kind of came into my head. One is when you say you don't know what modern cosmology is, I think we'd probably all agree modern cosmology is based on the four fundamental forces, the four fundamental forces. So we believe the entire universe can be reduced thus far to four, and actually less than four, but let's just start with four. Electromagnetism from Maxwell, the weak force, which was awarded the Nobel Prize in the 70s, and the strong force, which dictates the behavior of subatomic particles inside the nucleus.
Nobel Prize in 2004, that one.
A Nobel Prize in 2004, there were a lot of people strutting around departments because everyone knows everyone, you know, and felt somehow it was contagious or something. And the recent Nobel Prize in 2006 for the microwave background. But the fourth force being gravity, for detection of the radiation left over from the Big Bang.
Gravity will be the Nobel Prize in 2020.
You fast.
Yeah, this is a New York audience. I thought I could talk in my New York clip. Whenever I travel, I try to slow down. I don't bother.
The volume.
So we're not in Texas yet.
Oh, yeah. So those are the four. Gravity is the fourth. Okay, so really, in some sense, we've unified three of them. All the matter forces, weak, strong, and electromagnetic. We have not yet unified gravity with the other three. And that's the great ambition from theoretical physics. Now, we're all here talking about cosmology. We're all coming from slightly different angles. I think we'd all agree modern cosmology is an attempt to apply that short list to understand how the universe was created, how it's evolved since then, and what it's made of. Is that the short list?
Yeah,
it's appeared,
that's the
not
short
created.
list. What was that?
Appeared, not created.
Appeared.
Not created.
Brings
strange connotations.
Particles into,
the quarks and the leptons?
Right, so how structure is formed and what it's made of. So,
but also, a very short footnote here. I believe, I mean, because you say I was talking about 100 years after, you see, the thing is that we can sit now here for us and discuss this is because, you know, we have this development during the 100 years. You know, we're using quantum mechanics. There was a lot of development. Now, I believe that neuroscience is not yet is like physics in the beginning of the century or something like that. So clearly, people that are doing this thing, while this thing is very complicated, this thing is, maybe the most complicated object in the universe. Now, and it's going to take some time, I think, to really come to satisfy your appetite, you know, for this thing.
Neuroscience is theory, just like anything else.
Yeah, no, but I think we're really, though I believe a lot, and I believe from there we understand even questions that we were discussing before, and eventually, you know, within, I mean, I don't want to put time things there, but somehow that it is clear to a lot of us that studying this object with the new techniques and stuff like that is going to give us answers to a lot of these things that you asked. But we are, admittedly, we're far behind.
You started out by saying this is going to change our view of the world. And
No.
ourselves. So I'm trying to understand what in the four principles is going to impact on human thought.
Well, let me tell you something. Suppose that I'm ready to say, I don't know, I'm speaking for myself, and a lot of my colleagues, physicists, will say to you that the universe is just appear by chance. It's just fluctuations from nothing, right, for this thing. Now, this statement, right, for this thing, when we quantify this statement, and suppose that I have all the experimental observation support that I have to say this statement, I believe this statement should change your mind on a lot of things. Right? I mean, yes, sorry, please.
So my question is, there seems to be a basic tension here between what Professor Hu is saying and the context of the Dark Ages and this modern view of science. And so I guess my simple question, so I'll give a simple question of the background. The simple question is science ready for prime time as a worldview? And what I mean by that is that, you know, if you bring up a question like the intelligent design debate, we know that moderns, if we're here in New York, people are very dismissive of superstitious people. But if we put it in the context of like the war in Iraq, on the one hand, there is a context, a frame out there of modern democracy being used to free the poor believers in Iraq and replacing the old system this breakdown. So, and then at the same time, they use the believers in the Midwest and say things, well, you know, our boys are eating sand so that they might have freedom. They use the old Christian, Judeo-Christian beliefs within the country to send poor Midwesterners to war. So these have really implications, and it seems that science wants it both ways. So anyway, so here's the last quote from.
I mean, you are not identifying modern science with the present White House, right?
Yeah, please.
I know, I'm not. I'm just explaining how the context of science is being used both ways. So here's the final quote from.
This analogy, I would feel very.
Science itself is abused and abused by people just as easily as religion or philosophy or anything else is.
And science ever abuses believers.
No, science itself does not abuse believers. Those who wish to abuse believers will use science to abuse them.
Exactly. Yeah.
Science itself is noble and straightforward. And it has never attempted to co-opt anybody's non-scientific beliefs. It is those who choose to use science to co-opt other people's beliefs. That's why the question is not a problem. Science has always been ready for prime time. It's a teenager.
Right.
But those who used to use science to abuse, I have no faith or sympathy for them regardless. So it's the anger is misplaced under those circumstances. It's misplaced not towards science, but toward those who would abuse science, just as those who would abuse Islam, or those who would abuse Christianity, or those who would abuse literally anything.
There was a gentleman here.
I'd like to make an observation on the question on the physics of the discussion. The whole sequence of the expansion, the Big Bang in momentum, and the slowing down because of the gravitational attraction to maybe to a point of a null, and then enough space is created to produce a dark force that causes the expansion again. Does that seem entirely too convenient? And you know, it's just so perfect. Just upon it's needed, it appears. Maybe it's a similar question, but can it not be the different manifestation of the same thing? It seems so perfectly sequential, and you know, one knows where gravity comes from or what carries it and what the dark force is either. since it's so perfectly fit in, just when it was needed, it came.
So you distrust
Is it the same thing?
But I would just say it wasn't needed. It was one of the, Robbie, right, we observed and we were surprised with it. It wasn't needed to explain anything.
Really, but it sounds like almost like a sine wave. Just when it hit the null, it went the other way. It sounds like something rebounding.
It wasn't clear that we were at the point of the null, as you described, which I think by that you mean that the universe was about to recollapse or something. We were not near that. So it was even stranger. We agree it's stranger for the opposite reason. It's strange because we don't need it for anything. What's it's doing there. The universe tends to be very economical. It tends to do things that are what we would call natural. And if you study basically all of physics, mathematically it can be reduced down to the idea of the path of least action. Take the simplest path, and that's the correct path. Mathematically, that's literally how we do the math. And so this is surprising because it seems to be something unnecessary.
It almost seems like
it's unnatural.
Positive gravity than negative gravity. It might not mean that is gravity.
Well, no, but probably what's happening is we don't realize it's the simplest path in a much more complicated system. Maybe the universe isn't three-dimensional, maybe it's 10-dimensional. Maybe the extra dimensions are doing something, and that's why it's showing up. So absolutely, we try to use maybe a similar intuition to the one you're getting at, which is what would be natural, what would be more kind of holistic as an idea, and simplest and cleanest. And in that sense, we're using aesthetics to try to discover what we think is going to be a fact about the world.
It's amazing.
My wife has suggested that when people speak, why don't they just identify themselves?
Oh yeah, that would be good. Yes.
Stevie Cass, I'm editor with the Sort of magazine, but I just wanted to ask, just really following on from your previous comments, in terms of use of science, would you consider that someone like Richard Dawkins, who is an ardent atheist man who feels very, very strongly that his science compels him to that belief and has therefore made attacks on the witness establishment based on science, is also abusing science, however much we might applaud his ability to attack the intelligent design critics?
Yes.
Richard Dawkins, I believe, is abusing science to a degree. Not perhaps as great a degree as those who wish to deny that the world's climate is changing. But nonetheless.
But you see,
the problem is it is relative, and its effect on science, it's profound. We're getting back. I feel that it is no longer necessary to have scientific knowledge and non-scientific knowledge be at conflict with one another. The holistic understanding is extremely important. I listened to a very compelling radio show by actually I believe it's a chaplain for the United States Army, if we dare to wander into political environments again. But he said, he tried as ardently as possible to tell his military superiors that the war in Iraq cannot be won by kinetic energy alone. It cannot be won by physics. If you try to say, well, we can put more, we can blow up more things than the enemy, thus we can win, is wrong, because the non-scientific motivations of those who are in Iraq and are not happy with Americans there, or those who are, whomever they might be, are very strong, and perhaps even stronger than the amount of physics we can induce in that part of the world. We must take all of this together as carefully as possible, and it's a shame that we all can't. But it is a very difficult question. Even the wise men of our civilizations have struggled with this question, just as we struggle with it today.
But you see, this is, I have a little different answer from this one. I mean, I don't know Dawkins, and I know the book. I have not read the book. I don't need to read the book. I have my... You
need to read the book, Dimitri.
What I mean, no, but I mean, it's a matter of time. I would love to have time to read the book, but what I'm saying is his conclusions, I'm not against his conclusions, but okay. Now, what I'm saying though, it is, we're not living, I mean, I love that we live in a world that you are describing, in an idealistic world, and that's a world maybe eventually we're going to live. I mean, we're not living such a world. And I think that Dawkins, which is a very prima facie scientist in biology, he took the time out to write such a kind of book, is because we're living in a very extreme hostile environment against science, right, for this thing. So please, we have to keep that in mind also, that someone should answer to all of this. Right. Careful with my words now. Yeah. Now, to intelligent design and all of these things that's going around, and all of us, we sit in our offices and we do our jobs, and we're smiling, right, for this kind of thing. But a lot of people there, they don't have the same kind of data and input that we have, right, for this thing. So I would give him, I repeat again, I have not read the book. Maybe he is overdoing, I don't know, right? I have a lot of respect for him as a scientist. I have heard him sometimes speaking about, and I really have respect for him. But someone has to do a few things like that. Also, there's a French also has done the same thing now for this kind of thing. So to be a balance there a little bit, right? And I don't believe that the world has to be hostile. I believe the world, I love to have a world that all of these things contribute to the same kind of thing. But I cannot see the one guy that comes there with a cannon and I go there with a red kind of
flower
rope,
that
with
you
a
stick
flower.
into the cannon.
Okay, fine.
No, Dimitri, you're right. You're right. We do not live in an ideal world, and so that we have to have, I guess, soldiers on both sides fighting the bad fight in order that the truth come out. But yes, I agree with you. I believe that if we use the blunt instrument of, you guys are superstitious, bang, 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 we're going to have a problem.
Yeah.
As we all know, the truth is complicated, and we must not assume that people we're trying to educate are too stupid to understand that. We must come about them and explain to them, in my opinion, that intelligent design is an idea, and evolution by natural selection, shall we say, is an idea. What are the differences between the two of them? One is a scientific theory whose hypotheses have been confirmed over and over again. One is a non-scientific hypothesis which either has never been proven or can never be proven by the basic premise of its hypothesis. And it's okay to have both kinds of knowledge, but when you are making a decision about how you're going to run your country or how you're going to run your life or how you're going to raise your kids, you must know the difference and decide accordingly. And I'm willing to go that extra mile, take those extra minutes or hours or years to give folks that enlightened, better not use enlightened, that additionally educated opinion, so that educated knowledge, so that they can make that decision for themselves. It's not for me to make it for them.
Perfect.
Whether I'm a scientist or not.
100% agreement with this thing, but they should know what is the kind of the alternative there in to decide for themselves. I'm going to tell them what they're going to do, but at least to know it, what it is on the table.
Well, the cosmology,
Excuse me, and then the gentleman there.
Sorry.
Given the expertise in the room, I wonder if you could talk more concretely about some of the revolutionary observations that we referred to in the beginning within cosmology in the last 10 years, so we can be enlightened, and I do use that term, enough to know what the latest debates are. Okay.
The first thing is that it is, let's say, I would start with the observation that they found that the universe is not only expanding, but is accelerating. That came out about 98 or something like that for this thing. And then they saw these objects that they call supernova, and somehow we're taking light from there and all kinds of with telescopes, and what they found is that these objects were a little bit further than we will be in a normal so-kind universe, right, for this thing. And we have now a lot of evidence that we're living in a universe that is not only expanding, because usually you would expect the universe to expand with a deceleration, right, because we have this big push in the beginning. Gravity is attractive, as you all know, from when we were kids and we're falling down, right, for this thing. And now, what is something there, and you would expect that the universe, yes, expands, but decelerates. Now, what is happening is, in order to see that it's accelerating, it must be a new force somewhere there to help it to fight against gravity. And that's new force, that's in the beginning, the journalists were calling it the dark force or something like that, is what she was calling it the dark energy. I mean, we all call it the dark energy and stuff like that. So that was something was unexpected. I have to say it was cold. I was in this meeting in Marina del Rey in California, in February of '98, and it was really cold water. I mean, really cold water in such a kind of weather outside, you know, for this thing. I mean, it was everybody, and it was a good group from Berkeley and from Harvard, so we knew that that was no funny business there. It was real for this thing from the beginning. It was cold water, so that's what he was saying, was we're really surprised, and we still are, but we got used to it. Now, that's one thing. The other
is that hypothesized or has been proven?
It's proven. It's experimentally proven.
The explanation for the re-expansion is that
for the accelerated expansion?
Yeah.
There is no explanation. We're just calling it.
Calling it, yes.
You're measuring a form of energy, essentially, indirectly.
What the new force is doing.
Well, the new force, it's against gravity. Gravity tries to hold the whole thing back. But this thing should be a little bit bigger than, you know, like we have one force that way, one force the other way, right, for this thing. And this force is not one of the usual forces. That's what, well, the fifth force is another, I don't know.
It's definitely gravitational.
Gravitational, but the origin is very clear. So this thing, while we have the framework, what is happening, we don't have at this moment the model, that it is a well-accepted model that I put on the table and say this is the model of the Levin model, right, for this, whatever it's going to be, right, for this kind of thing. So what it is going on now from this thing, so that was one thing. The other thing was, which I think is also fantastically interesting, it is that we have this W map, which is a kind of NASA satellite, that he observed. You see, from the beginning, we have the universe was expanding, and we have a lot of energy, and the universe the temperatures were very, very high. As the universe is cooling down, as expanding is cooling down, and still we have what we call the cosmic background radiation, right, for this thing. If the cosmic background radiation, and this has been measured here in New Jersey, not very far from here, 65 Penzias and Wilson, and they found out that there's something like 2.73 degrees Kelvin. That means if you go somewhere in the universe, there is nothing there, it's going to be 2.73 degrees Kelvin. Now, if we were living in a universe who was homogeneous and isotropic, that means that everything is in the perfection, that's the beauty now, right, for this thing. You would expect for this thing to look around, and everywhere I look, it will go to look the same, right, for this thing. Of course, you don't want to live in a universe which is homogeneous isotropic, because otherwise we will not be here, right, for this thing, right, for this thing. So it was imperative that when they make better and better technology, at some stage, if they look at this part of the universe and this part of the universe, to see a little bit of difference in the temperatures, right, for this kind of thing, because otherwise things will be very homogeneous isotropic. And in 2003, I mean, there was some indications before, we have this, I think you have written a book on this thing, right? With this, right?
You can just read my book.
So what is happening is they really measure this kind of differences, which we're talking not one, almost per million. That means now that the difference between here and here, 1 per million difference in degrees Kelvin, right, for this thing. And it's because of these differences that we are living today here. We're here today, right, for this kind of thing. And it's an amazing kind of measurements for this thing. The precision is beyond any expectations. And also that supports, because people like the older of us here in the beginning of the 80s have predicted what kind of fluctuations we're going to see, and so on and so on. And this fluctuation, if you see the curves that the experimenters have produced and the theoretical predictions, you cannot see the difference from there, right? And that's confirmed somehow that we have a kind of picture of what we know what they're doing. And that's what I was telling in the beginning. It goes back to, I mean, the measurements that they take, they look at the universe as it was 380,000 years after the Big Bang, right, for this thing. And of course, the reason that we can do this is because the light has a finite velocity, right, for this thing. If you look at the sun, you don't look the sun, I mean, the picture that we have in your brains now, that we were talking about, whatever it is, how this thing is working, the sun out there, it is, how is the sun 8 minutes before almost, right, from this, because it takes time from light to travel from the sun. Now, if you go further back, and you have the technology that we have now, we can go and see this thing as far as we can, and today we reach the point of 380,000 years after the Big Bang, which is something fantastic, never happened before.
If I can mention 2 real quick scientific discoveries within the past, say, 12 months or something. One is called the discovery of the baryon acoustic peak of the Big Bang, which means that basically a bunch of people mapped millions of galaxies and tried to see if there was a pattern. And sure enough, there's like ripples in a cosmic pond, which suggest indeed that something actually happened like a Big Bang. But so we'll get more detailed technically if you want. And then the other, and I think is building on what Dimitri is saying, is the discovery of the polarization signal of the cosmic microwave background, which means that early on in the history of the universe, there was an interaction between the expansion of the universe and something called the hyperinflationary expansion of the universe, something that is necessary to make our universe the way it is today. There's never been any experimental suggestion even that this hyperinflation actually happened, but this is the first time that maybe it might have. These are just two simple things that happened in the past year. We can talk in greater detail later, but...
This is the gentleman there.
Yeah, okay. This attack on evolution, the attack on cosmology too, I guess I could direct it to Mr. Toole also. And it's been stated here sort of that politics is not scientific. And yet, it can be and must be in order to recognize where these theories are coming from against evolution and cosmology. Why, where, we have to understand these things. Now, I'm so surprised at myself when you started talking about how the universe is expanding and it's finite. I was taught that it wasn't. And from a political point of view, I went along with it, but now you're saying it, and I accept it. Who am I, because I don't know science.
Okay.
But this is so important about this whole scientific question because there's no other way. Most of us, I wouldn't say us, or less educated, where are they going to learn these things? And it's because of the political question, and at least to understand the scientific factors that prevent progress of all of our minds, or most of people's minds. So this thing has to be taken very seriously. Because you all seem very unified on this.
I'm sorry, but before we get back to politics, maybe we can talk a little bit more.
No, it's not politics. It's not politics.
Why? That's the point.
It's not politics if it is Republicans or Democrats. It is the politics of how science is going through the people. Because if we miss this thing and if we lose out there, then why you're doing this, right? I mean, we become a kind of sect like the ancient Egyptian sects that we speak to ourselves. We're taking our Nobel prizes and we go home and we're happy, and the society pay no attention for this kind of thing, and then we have all this kind of people that going around and they do whatever they do, and that's why after we come to the end like that, right?
Professor Du, I am very interested in what you have to say about this, especially in your comment of scientism. The way that, for example, current mainland China is really following a scientistic religion almost. Please talk to us about that.
Well, I think, it's a fascinating question, and it's an important one. I totally agree with your description of what a good scientist is doing. Once the good scientist begins to address questions that are not directly related to the scientific work, the person, in fact, can either simply falling into certain kind of ideological struggle, or actually plays the role of a public intellectual of the scientific community. For any professionalized work, the humanities or psychoanalysis and so forth, you have people who are dedicated to very specialized inquiries, and you find the truth, the structure that actually works, and you don't have time to deal with the non-scientific community, because that's how you become a first-rate scientist, right? And yet the scientific community itself has such power, influence, and authority. And so a lot of people, as you pointed out, misuse science, abuse science in order to advance their agendas. Now the scientific community, this first-rate scientists doing work very, very well, not only conceived, but very, very detailed experiment, are also important intellectuals in the community. And they have to play the role, some of them, not all. The scientific community, indeed, quite a number of them. Steve Weinberg, you may not accept his view. I think you like him.
Yes, I like him.
A lot of people believe that he's a missionary, right? He's atheist. He's a missionary. And then you have another professor, Gingrich.
Yes.
Now, Gingrich, you take him seriously in the following sense. He would not talk about the design, the intelligent design in terms of capitals, IG. He used the small letters. So he opens a new area for some kind of communication. Now, you may consider that totally unacceptable within the scientific community. That's fine. But the question is important. You need to also, the question raised here, how to deal with this particular issue.
Yes.
Dimitri, I had a question.
Yes.
I was synthesizing Jason's earlier question and the very good question you asked about advances. How does this affect our view of man? I mean, man is prized as a creature both of sexuality and consciousness. If I can think of two ingredients that would describe mankind, sexuality and consciousness. Well, the sexuality part we put to the side. But But consciousness seems to be able to, for instance, exist without the corporeal essence. I mean, if you talk about the creation of these robotic, these robotic creatures, that means you could have consciousness existing without man as we know it.
Careful now.
Kind of address the Turing.
Careful.
The Turing
That's right, because then that will be a bit strange, because maybe eventually, and here is one point, I disagree in many points with Penrose, but maybe here's a point that I would agree with him, that I don't know if the artificial intelligence is going to give the whole consciousness kind of thing. From a point of view that we have, it now goes to Gödel's, incompleteness theorem and stuff like that, with the meaning that maybe it is this algorithm that we're talking about, and she has written a book on this also, that the algorithm that we're talking about, because a robot is going to have an algorithm or that, and if it work, maybe that's not enough finally to give the whole thing. You look out the intuition, that this which is human. Okay, so by saying this, I'm not saying that humans are something special from the other parts of the evolutionary process, right? For this thing, but maybe I believe that it is the robotic stuff. We have to be a little bit careful if it's going to be ever correspond to our kind of thinking we have. I repeat again, I'm talking about from materialistic point of view. I don't put any other things inside there to make sure that we're not
But why not?
mad for this thing, because it may be that it is involvements there, maybe the quantum comes into play and stuff like that. Now, if it is possible to copy completely our brain, then it would be fine, for this thing. But then if you have a complete copy, that would be a different kind of thing. But such a kind of only with algorithms, to do programs, then I think we're going to have a program there.
If I could just touch this just quickly with Turing. Alan Turing is the great mathematician, famous code breaker, really amazing person who was the first person to realize that in some sense thought could be mechanized. He's the first one to sit down and say, I could write a simple program that could teach, well, he didn't say it this way, but it could teach a machine to think. He really is the father, therefore, of basically software, of computers. So after Turing has this leap that I could make a simple algorithm to get a machine to add or divide or multiply, you have the whole world of artificial intelligence saying, well, then I can simply design a brain. If I can make an algorithm, then I can get a brain to do what the human mind can do. And the problem where that breaks down is you can actually prove that you can't, or the human mind is not capable of writing an algorithm complex enough to make basically a conscious brain. However, what you can also show is that since we evolved from simple algorithms, so to speak, maybe you could write a few simple algorithms and get them numerically on a computer in some sense to evolve. And that those algorithms could evolve a complexity that could be great enough for consciousness. So I can't design a conscious mind.
Emotions. Is the robots going to develop subjective emotions?
There's no reason not to think that they wouldn't also follow out of algorithms. And that the algorithms are just much more complicated than the kind, you used the word mechanistic, simple mechanistic one that I might be able to write. I can write an algorithm that gets two black holes to fall together under some force laws, but I can't get consciousness that way. But it doesn't mean that it's not possible, it just means that I'm not complex enough to design something.
Also, that's the way Freud theorized.
Don't forget a word which is called Gödel, right, for this thing. I mean, this is very, very important kind of thing. I mean, he was a kind of, at the end of his life, a weirdo here, but this theorem that he proved, or this class of theorems that he proved, that somehow things cannot, I mean, you need something more than an algorithm, right, to decide between what is, because he was talking about the Turing machines and stuff like that, and so this is going to be with us all the time, right, for this, that the axioms, you cannot prove the whole story, that if something is which you feel that it is true, but you cannot prove it, kind of formally. Let's put that way, what the mathematicians are using, right, for this thing here. And that could play a very important role on this whole issue. But I think we're so far behind of getting to a point that, we have, I'm sure that we're going to build robots, we're going to be very, we have a long way to go with robots, and Piet was very correct when he was saying that we are using objects, not subjects, right, for this thing. So again, I think, it's not that I would like to push always in the future, but again, with respect to the units that he was talking about, we are very far behind in building subjects instead of building objects. And before we come really, we have to go a long way, and I think we're going to see I don't know if this generation is going to see them, but I think I'm going to have fantastic robotics evolution for this kind of thing. Now, at the end of the day, if we're going to come to overpass and think something clever, I don't know, but we have to be a little bit careful for this. Yes?
I like the fractal idea as one kind of guiding principle, as long as they're not self-similar fractals, and there's qualitative change as you go from full part and parts of the whole part transformations. But I wanted to throw another kind of little wrench into this. From a psychological point of view, there's a lot of discussion about belief and so on. And of course, the truths that we hope to be true tend to be scientific truths. Those are the ones that we all sort of agree on as being true. But they're provisional. So there's really no clear relationship between truth and conviction. And I say that because from a psychological standpoint, both in normal subjects and in pathological cases, psychopathology, organic brain pathology, false beliefs are held with much greater conviction than true ones. So this is really an interesting phenomenon that whether it's a delusion, a psychotic illusion, the debate between George Moore and Wittgenstein about rock bottom beliefs, and Moore said, "This is my right hand." That's a rock bottom belief, and Wittgenstein wrote a monograph on certainty, dealing with that. This is a rock bottom. This is a core fundamental belief. This is my right hand. But Wittgenstein's brother had as you know, had lost his right arm. So and probably has hand and limb phenomena. And if he closed his eyes, he would have sworn that his right hand was still there.
To any given individual, conviction may not be distinguishable from truth. But to the universe, there's a big difference.
Very good.
No, that's
very good. That was Poincaré was saying that there is an objective reality. He took it almost from my mouth. There is an objective reality, and this is what people with common, brain or common mind put it together as true, for this kind of thing.
As human beings, all of us know that the emotions have a reality that transcends the objective reality. This chair has an objective quality, but your emotions or my emotions, they are really different from each other.
Yes.
There is a qualitative difference. And to make everything identical, seems to me, we need not to understand the complexity of reality.
No, but,
and of course the history of human thought
but science
talking about.
But science that we're talking about here
as many stars and so on. And you have no doubt at all with any of the issues that Professor Tuchel raised at the beginning. There is a completely different, until you find a gap between the two, it seems to me you can go on and on and on from the study of the context.
But you see, that's what is the thing, science, it is somehow, by definition, is related with these objects that we all consider to be common and we all have common sense of it, right, for this. Then we have this other kind of thing, like a poem, right, which different people may have different reactions to this kind of thing, which I'm not saying that they're different kind of weights, but I'm saying this is something that it is a different realm and then we can discuss this kind of thing. Now, I don't know if in the future that comes back to your question. All of this would be able, the human beings, or neuroscientists or something, to explain all of this kind of what it means when I hear, a kind of nice poem, why most of us would consider to be a nice poem, and what it makes to our cells, what synapses are going up and down, and so to give me this kind of esoteric euphoria, right, for this kind of thing. But again, we have a long way to go for this thing, but at least for the moment, science, and I talk about physical science, is related with these things that we all consider to be common. As you say, for instance, what is this kind of thing? I don't think we can go further than that.
And I think most scientists... Well, I was just going to say, most of us have an emotional reaction to things that we discover. I mean, I think that that's widely underestimated.
Also, scientists also are human beings, with all kinds of emotions, and of course we take this to account. We try as much as we can to leave this thing aside and be as objective as we can. But yes, please.
Someone said earlier, and I thought this was really fascinating, even though I didn't really understand it, that we, and I took this to mean human life, we're the contamination or the junk that causes the space-time to bend.
Yes.
And I was wondering if you could explain a little bit more what that means.
What was means is we're following, I think. Okay, let's face the thing. We were saying that now we believe within a few percent, what is the stuff that the universe is made of. I mean, the elementary stuff, the fundamental stuff. And this is dark energy, most of it. 20% or 23% of what we call dark matter, we more or less know what is this about, and we are made up for the 4%, right, for this thing. So for the whole fundamental stuff of the universe, we are really a contamination for this thing. Now, why we say that this thing? Because it is of this Einstein's relation that, space and time and matter, the curvature of space and time is related with the energy content of the universe, and so on, right, for this. So it's because of this kind of thing we say, and we make this remark, right, for this. If you look at Einstein's equation, now we're going deep water here, but so in one side it is just geometrical notion, which is the space-time properties, and on the other side here it is the energy material of the energy matter material of the world, of the universe.
How does that relate to the idea of the beauty of the universe?
That's now beauty of the universe. I don't know. I think we cannot see the beauty of the universe is the universe, right? By definition, is beautiful, right? I mean, what we can say on this? I mean, it is not like a nice lady or a nice man that
you're talking
change your opinion. I mean, the universe. That's it. Now
you're speaking like Job. How do we know the will of God, right? Yeah. How do we know it's beautiful because we say so?
However, we do use aesthetic principles to solve problems.
Yes, but this is our...
That's really strange. Right. So, you have Murray Gell-Mann, a Nobel Prize winner, comes along and says, oh, if I arrange things in this nice symmetrical pattern, there's a particle missing that we've never discovered in the universe. I'm going to propose that particle exists because now it's a nice, beautiful, symmetric. By beauty here, I mean symmetric. Literally, I'm referring to symmetry. And lo and behold, we discover this particle.
And we call it beauty.
Yeah, we call it beauty.
I recall sometime that they asked Einstein about some equations that they were not beautiful. Someone was making a joke on him, and Einstein took it very seriously and turned to him and said, I leave aesthetics to my tailor. Right?
He had a tailor?
I don't know. Maybe. Yes.
A question, especially in response to this idea of patterns, and you also talked about fractals and observing how different elements form along similar structures. And I wonder also about these underlying principles of physics and how they reveal themselves in just everyday life. Or, I mean, people have talked about even the way, the stock market moves, or traffic forms, or city growth, patterns happen. So I was wondering what you might have to offer about that.
Well, the brain's
That's a kind of more practical kind of thing.
The brain is a fractal. It's an example of a fractal. Usually what happens is if you want, your brain, you need a large surface area to get more and more clever progressively, as we evolve. And it would be very bad if our brains also had to have a bigger volume to do that. We'd have to have these really big heads, right? And that would become unstable. So what the brain does is it folds. And they make folds on the folds, and there are more folds on those folds. And that's classic fractal patterning. And so what fractals do is they have a large surface area because of all these folds, but a small volume. And you can't do that without a fractal, really. Eventually you have to go fractal if you want to do that. So the brain is an example of how we become clever enough with small enough heads that we can lift them. And you do the same thing, the blood vessels and the lungs have this kind of fractal patterning for similar reasons. You want large surface area, small volume. So there's examples, ultimately the way we think about the world can be related to the laws of physics that we inherited.
Yes.
And also our experimentation. I have a 6-month-old baby who's testing everything. Is this hard? Is this soft? What's it taste like? I mean, she is an experimentalist, essentially, And we all are born that way as experimentalists, and that's how we develop this intuition about where to lay our feet, how hard to press, how high to step, and all of these things we've really acquired through experimentation.
And also, you see, there is this part of biology called evolutionary biology. And among some of these subclasses there, they were trying to explain why we are in the outside the way we were, right, for this thing. And of course, this is some random evolution that we have. For instance, for the heads, if we had big heads, when the chips were up in the trees there, the ones that they have such big heads will be, with all the branches that will disappear, right, for this thing. So with the smaller heads that would survive for this thing. So, it's so much stuff that is built into this kind of thing, which all, of course, are physical processes, right, for this.
Let me just give you a real simple example. I have this little bit of cup of water. If I swirl it like this, you see little lines in it, right? That's why those spiral arms are there. Same process. A fluid swirling, creating density waves that are spiral.
It's accidental. Is for today now?
It's all connected.
We have an exhibition.
And this is all there. I'm surprised to see.
From everyday things come cosmic things. The fractal stuff is just one of the most elegant and beautiful things I've seen. But I can do that with swirling water like this. That's an example.
There's one last question, and then we'll wrap up.
Behind there.
Oh boy.
There's one behind you.
Two more questions.
Professor Levin brought up 10 dimensions, brand new fine theories. In your research in cosmology, do you ever think about the causality of the universe before it? Because there were some theories that would say, or a bigger universe, or more dimensions, or what have you. Is that?
Because am I interested
about what the universe or space and time?
Okay, I think that's interesting. A little bit we think about it only in the context of the possibility that the universe looks like a ginger root, so that we're like a plume off of this root, and our Big Bang is like the trunk of that plume, and all we see is this branch off the ginger root, and we think that's the whole universe. We simply cannot see past that sort of what we call the Big Bang event. But it's possible it was just a plume of a larger space-time where there have been many plumes. And in that sense, we are contiguous with one colossal, you might call it a multiverse or megaverse, I think is the terminology that's going around. That's probably a little better. A megaverse, a bigger universe which has many plumes off of it, each of which looks like it had a Big Bang. It might have slightly different features than the one that we happen to live in. And that's a tenable possibility. So to distinguish between those possibilities, we'd like to have data. We don't have data. You described being able to see back to the time when the universe was a little over 300,000 years old, but I can't go back far enough to really penetrate this, creation or this appearance event. But it doesn't mean that but it doesn't mean that there won't be data, and that there won't be data that comes in surprising form, that comes in the form of accelerator experiments where we're smashing together subatomic particles. We might there discover things that tell us about how the universe was created. So the other way around, by looking at the large, we discover things about particle physics, about physics on the smallest scales. We might now be looking at the smallest scale physics experimentally and discover things about the universe on the largest
Because don't forget that the universe is now big. But at some stage at the beginning it was smaller, so it was really, and that's what we're concerned about. It was really its origin. After that, when people have explained this, that's the real, the $64,000 question, it is what happened in the origin. That was the kind of thing here.
You're almost trying to reproduce those conditions when it was small. And
that's why we build these accelerators that are going to be in Geneva, for instance, coming within a Large Hadron Collider and stuff like that. We're going to hear. That's what we want to learn about. So it's all related.
One last question.
Yes.
This is really for Professor Levin. When you were talking about the fractal nature of the brain and the folds, doesn't that have a counterpart in string theory? and the idea of there being folds and the folds possibly representing different dimensions?
Well, that analogy might be, there are definitely analogies with physics and with biology that can be pursued. In fact, the book that you referenced, How the Universe Got Its Spots, is because there's a direct analogy between how certain cosmic patterns are imprinted and how literally the leopard got its spots. And actually Turing, by some coincidence of conversation, was one of the people who realized things about the leopard getting its spots. That analogy in particular would be a tough one to pursue, the one that you're going for between the brain and dimensions, because dimensions, the strange thing, it would almost be as though if our brain could occupy another dimension, it wouldn't have to be fractal. It could fill itself out in that other direction, so to speak. It's because, for whatever strange reason that we don't understand, if there are extra dimensions, we can't occupy them. I don't know why I can't stick my hand in that other dimension. There are theories that it might be too small, that it's literally wrapped up like a straw, that in a sense I'm sticking my hand in it, but I don't notice because it's going round and round and round the space. Or there are theories that we're confined to something called a brain, that matter is locked onto this brain.
With, not this brain.
B-R-A-N-E. It's supposed to be a joke. It's bad physics humor. P brains, D brains, that sort of thing. But so I mean. So that analogy might be difficult to pursue, but it's it's interesting to think about.
Thank you very much.